Today, we'll cover how to write a benchmark in Go. So why is benchmarking important? Well, it all comes down to performance optimization, which is a critical part of software development. So what we see is we release a version of a product, then we do load testing in our QA, and sometimes we see performance issues which we need to debug and resolve. Occasionally, the product goes to the customer. The customer then sees a corner case with some performance issue, which then comes back to us, and we need to solve this. So benchmarking is a critical part of this process because it gives us data which we can use to identify specifically what changes we need to make. So let's go through an example. So our application processes JSON data once an hour, and we see that some customers, this processing takes longer than we would expect. So one thing we did is we ran the Go performance profile, a pprof, to generate this flame graph. And in this flame graph, we see that JSON decode takes a considerable amount of time. And we generate the JSON data in a separate job. So perhaps we should be using a different decoder. Perhaps instead of JSON, we should be using a different format. So let's go ahead and create a benchmark to figure out if something else may be faster than JSON. Okay, so first we're gonna generate some test data, and I already wrote this part. This is not a benchmark. This is just generating some test data. We're gonna be using basically a struct with these fields. We're gonna also have some slices in here, and we're gonna generate 1,000 files. And we're going to generate the data in JSON. And we're also going to generate the data using a binary format using the encoding GOP package. So this is just the main file that just generates some data. So let's go ahead and run this. Go run main.go. And it generates some data, JSON data and binary data in the test data directory. And one thing we notice right away is that the JSON files are approximately twice as big. So this gives us a key that perhaps the binary format may be faster just for the simple reason that it's smaller. All right, so let's jump into creating the actual Go benchmark. Go back to our editor. All right, so a benchmark is part of the testing package. So we're going to be using the testing package to create the benchmark. So func benchmark JSON import. Whoa, let's slow down here. All right, so one thing we notice here is that the start is benchmark and not test. So this is the convention. And then we're using testing B. So this can run just as a normal test, but it can also run as a benchmark. So now we need this loop for I equals 0. So this is kind of a standard loop. It can also be a range. So what this does is this number of iterations controlled by the testing package to basically run it enough times to give an accurate measurement, right? So things inside this loop are going to be measured. Okay, so what are we doing here? First, we're gonna read the file, right? And then we're gonna decode the file. In this case, it's a JSON file. So let's go ahead and read the file. And as another example, we're actually not gonna time reading the file in this case. So how do you not time something? Because reading the file itself is not super interesting. Yeah, it is relevant because the file size is bigger in JSON, but in this case, for this example, we're gonna skip that timing. So we can do this. We can say b stop timer, and then we're gonna read the file, and then we can do start timer again. So here's where we're gonna read the file. So and the function to read the file, we're just gonna use read file, and then we have 1,000 files, so we don't want to read the same file every time. Printf test data, and this is what we call this is correct. Copilot I. In this case, this is not going to completely work because we only have 1,000 files and we don't know exactly how many loops we're going to run through here. So what we need to do is mod this by 1,000. Can we simply do it here? Like this? Yeah, this will work. And then we, of course, need to handle the error here. And then data is our binary data that's being read in. So now we get to the part where we're actually going to be measuring the performance. All right, so we're using the JSON new decoder. And yes, Copilot, you're right. So get this into bytes. And then we're going to decode. Our file is actually an array of those samples that we showed earlier that we generated. So we're going to need the samples. And then okay, code samples, and it failed. So we decode, and this is all we need actually. But I like to kind of do at least some sanity checking. So we're gonna do a sanity check here. We expect 1,000 items to be in the file. Yeah, this is good. This is good. Okay, so this is our benchmark right here. So we're gonna benchmark how long it takes to decode this file. So let's go ahead and run this. So go test, and then to run, we can actually just do go test right now and see what happens, right? Because I mentioned it can be a regular test. So let's do go test. Okay, run directory, go test here. Okay, so no test to run. So it's not actually going to run the test. So I guess I was wrong about that. So a benchmark will not normally run when you do go test. So in order to run the benchmark, you go to specify the bench option, bench, and you can specify here specifically what benchmark you want to run. In this case, we do a dot. We're going to run everything. So let's see. Okay. It's running, so it ran. This number is the number of loops it made, so 362 loops, and this is the average time per loop, so about 3.2 milliseconds per loop. So we got a measurement for how long it takes to decode our JSON file. So let's now create another file using the encode gob package, which is another kind of standard library way to deserialize file. So since I already created this one, the benchmark for the gob is going to be very similar, except I need to read the binary file and I need to decode using the gob. It shouldn't take too long to create, so gob import. This is, yeah, so just gob. Is that it? Is that as simple as that? Just 2 changes. Let's run our benchmark. Okay, it's running. Okay. So Gob ran almost 3,000 times, and look at that. It's like around 7 times faster. Okay, so, just from this, we have enough data to go to our management and say, hey, let's use a binary format, and we can use a standard package. We don't even need to find a serializer library, depend on it. We can just use what the Go standard library has, and we get like a 7x speed up in decoding the data. So that's it for today.